Okay, so you have 2 almost empty bags of gummy bears. And you're one of those people that eats the colors so that at the end you only have 1 of each color left. And you decide that you can't choose your favorite flavor, so you're going to reach in to one bag and pull out a gummy bear blindly. And then you're going to reach into the other bag and pull out another gummy bear blindly. And you want to know how many different ways you could get a pair of gummy bears. So there's 4 colors, and you have 4 possible outcomes from bag A. Red, orange, white, and green. And you have 4 possible outcomes from B. Again, red, orange, white, and green. You choose your first gummy bear from A. And then you choose your second gummy bear from B. So these are all your possible outcomes. On this axis, we have the gummy bear that you choose from A, and on this axis, we have the gummy bear that you choose from B. Notice that for each column, what you choose from A comes first in the pair. So you choose red gummy bear in A, red comes first. Also notice that because there's a red gummy bear in A, which you could choose, and there's a red gummy bear in B, which you could also choose independently, you can get red, red. Also notice that for now, we care about the difference between red, orange, and orange, red. For right now, those are going to be considered 2 different outcomes. So what we've done here is we've essentially multiplied 4 times 4. You have your 4 possible outcomes from A, and you have your 4 possible outcomes from B. So now imagine that you had already eaten the green gummy bear from A when you started this whole process. So we're going to start the experiment all over again, except this time you only have 3 possible outcomes from A, but you still have 4 possible outcomes from B. So this entire column from A is going to disappear. And again, the multiplication holds. You still have 3 times 4. So it seems like we're coming up against a general rule, and we are, which is the whole point of this, which is for each experiment, you're going to multiply the number of possible outcomes for that experiment times the number of possible outcomes for each subsequent experiment. So let's say that you had a third experiment, C, which is flipping a coin. So you choose a gummy bear from A, you choose a gummy bear from B, and then you flip a coin. So this is the set of all possible outcomes in which you get a heads. So you could have chosen a red in A, a red in B, and flipped heads. You could have chosen a red in A, an orange in B, and flipped heads. You get the idea. So this is the set where you get heads in C. And this is the set where you get tails in C. I didn't have enough gummy bears to show you these side by side, but you could imagine that if you had these 2 different screens sitting next to each other, you would have a total of 24 different outcomes. You have your 3 from A times your 4 from B, which is 12. And then you have that whole set with heads and that whole set with tails. So total you have 24 possible outcomes, which is the product of the possible outcomes for each sub-experiment. So sub-experiment A, possible outcomes 3, sub-experiment B, possible outcomes 4, sub-experiment C, possible outcomes 2, and all together there are 24 possible outcomes because you're multiplying together those numbers. So let's generalize this. For our sub-experiments, where the first has n1 possible outcomes, and the second has n2 possible outcomes, and so on, there are n1 times n2 times n3 times n4 times blah, 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 times nr possible outcomes total. This is known as the basic principle of counting, and also known as the rule of product.